In this episode, we're going to look at data providers in PHPUnit. Hi, I'm Mark Bradley and welcome to Testing All the Things, a screencast in which we use live coding to demonstrate different types of testing tools and techniques. In this video, we're going to do the bowling game kata again. Unlike in episode 46, where we deleted tests that covered duplicate behaviour as a refactor, in this video, we're going to condense our tests down using data providers to make our tests smaller and easier to read. Let's look at the code. As with all my videos, I have my tests on the left and the code on the right. We're going to make a start on the bowling game kata in a second. We're not going to complete the bowling game kata. I'll get to a certain point where I'll leave it and allow you to pick up the code and try using data providers yourself. Let's make a start on our first test. Whenever I'm starting the bowling game kata, my first test is always the gutter ball game, checking for no score. This is the test that will always require me to write the least amount of code first. So we'll test gutter ball game. Okay. And we'll go straight into the assertion. So this assert equals. So we expect the score to be 0. So 0 for game score. And the game representation is always a string. So we're not going to score. We're not going to hit any pins with any of the balls. So hitting no pins in bowling is signified with a dash. So dash, first ball of the first frame, dash, second ball of the first frame, and then space to mark the spaces. The space marks each of the different frames. So we need 10 of those. So 2, 3, 4, 5, 6, 7, 8, 9, 10, like so. When the game looks like this, then the score should be 0. That's our gutter ball game. So we'll run that and see what happens. The test failed because the function score does not exist. So we'll fix that. There we are. So public static function score takes a string. We'll call that the game, like so, and then we'll run it again. So that should have solved that. So we've now written enough code because PHP is seeing the null returned as a 0. We can improve that by, instead of using assert equals, we can just use assert same. And that will do a triple equals check rather than a double equals. So let's run the test again. Okay, there we go. So we're now asserting that null is identical to 0, which is not. So our test fails. So now we need to write a little bit more code. Return 0. There we are. Okay, so we've written enough code now for our gutter ball game test to pass. I used to usually always use assert equals. I have now switched to using assert same because it gives you that triple equals check. So for things like, previously I've always used assert equals to do my assertions where I want to check things match. And now I've moved to using assert same for reasons like this test here. Assert same gives you that triple equals, so it doesn't just check that it matches, it also checks the type, which is really useful, especially in unit testing where you really want to be very specific about what is returned or what happens. The assert same gives you that confidence in the code that you're not going to get odd bugs because you could have returned null, 0, false here, and they all matched, which is not really great for writing tests where you want strictness and you want to know exactly what's returned. So I would suggest you use assert same over assert equals. Right, let's carry on with implementing our games. As you can see, we have now got our guttable game working, so we're going to move on to hitting a single pin with the first ball in the first frame. So create a new test. Single pin, first ball, first frame, like so. Okay, we'll copy this line, make it a bit easier. So we know that the game should look like this. We hit one pin with the first ball of the first frame in our game, meaning our score should be 1. Save. We'll run the tests. Show both tests. Okay. So now we are failed asserting that 0 is identical to 1. So we need to return 1 now if our game looks like this. So the quickest way to solve this problem is we'll just copy paste this game. Copy, so you can do if game equals this game, brackets, braces, and then we can do return 1. And we run our tests, and both our tests pass. So we're now moving on in the functionality. So let's take an approach. Let's take this test, and we can say first 2 frames. So we're checking if we hit a single pin with the first ball for the first 2 frames. So we hit one pin here, and we hit one pin here as well, meaning our score should now be 2. Run our test. Still not working. So what we can do, we can move this and say if it looks like this, then you return 2. Save and run. And our tests are passing again. Now we need to move on. Let's move on and check a single pin for the first 3 frames. So we put another one here, and then our game should equal 3. So run my tests, see it fails. So we're expecting 0. We're expecting 3, but we got 0. So our test is now failing as we expect. And there's an opportunity we could just do another if. But that's probably not the way we want to go, because otherwise we're going to be doing a lot of ifs, and this function will get very messy and not be great. So let's look at changing the way we're now implementing. Let's add a little bit more logic to our game. Let's put a bit more understanding of the scoring of bowling into our function. What we could do is we could do something like, we could split the game. So if we do something like this, so $frames equals explode. So we want the separator, which would be the space. So we get each of the frames as a string of 2 characters. And we want to explode the game. Like so. So now we can loop over. So if we do for each $frames as $frame. Okay, and then we can do if $frame, we can get the 0 element, so we can get that first piece here or here of the frame does not equal a dash. So we need to hold the score. So score equals 0, and then if that, yep, we can say $score increment by 1. We'll use some braces here. Okay, so this now disappears away. Okay, that didn't work. Yep. Return $score. That might work. Try again. There we go. So our test is passing. All of our tests are passing. So our change was successful. And we started putting more of our understanding of the game of bowling into the language of our function as well. So we've got a game which is passed in, which we know is this string representation. When we break down a game by spaces, we get frames. And we loop through the frames and add to the score. So this is looking quite nice at the moment. So we're now in a position where we want to start building up our understanding of scoring. So at the moment we can only score 1 point. Okay, but we know that in bowling, with the simple scoring system, so the just knocking down a number of pins, you can knock down up to 9 pins. So there are 10 pins, but at that knocking down all 10 pins is a special case, so we're not covering that at that point. So we now need to add a function that can start exploring that. Now what we could do is we could go through and add knocking down 2 pins with the first ball, and then knocking down 2 pins with the first ball in the first 2 frames and 3 frames, and continue doing that through all of 1 through to 9. Which will take a bit of time. So for this video, what we're going to do is we're going to skip to another test which just tests the scoring for all. So first ball, simple, all simple scores. Okay. So this is mainly, so I want to skip to this bit, so I want to show you the refactoring rather than how you go about implementing the bowling game kata. Okay, so if we take this one, so we can go 1 and 2, 3. And we'll leave the last one as the didn't hit any. So this is all of the simple. So we've got all of the simple scoring of 1 through to 9 and a 0. And the result for this should be 45. So we'll run our test. I think that last one fails because we're getting 9. We're just hitting 9 things that don't have a dash. So we need a little bit more complexity in our implementation. So we can do something like plus equals the frame at 0. So the score is incremented by the number in the first position for each ball, basically the first ball. Let's see if that works. And it does. So we are now in a position where we're ready to move on. But we've got a lot of tests that are covering duplicate functionality. In our previous video, we just deleted those earlier tests because they got us to this place. But we might not want to do that. We might want to still show this progression through our code, but we still might want to collapse down all of these tests because we've currently got we've got 4 tests that show us the scoring plus the one at the top that shows that gutter ball game. So what we're going to do now, instead of deleting these tests, we're going to use data providers to make the tests a little bit smaller. So what we can do here is we'll put it above our existing test. We'll start a new test. So new test, test simple scoring for first ball of any frame. Here we are. So that's our test. Now we also need a function that provides the data for that test. And what we can do, so our test will look something like this. So this assert same. We want expected score for game score game, like so. Now our function needs to take these things. So $expect to copy and paste, speed things up. So we want to take the expected score and the game. Okay. Now we need to create a function that provides these expected scores and games. So we can do public function provide first ball game score. Yeah. Okay. Now this function returns an array. Square brackets. So, and this function provides an array of arrays, and inside the arrays we want to provide the data for the game. One and this game. Okay. Oh, what I'm going to do is actually leave these tests existing for a bit. And duplicate, so it's 2 and 3. So, and then our special game, which looks like this. So we've now got a function that provides the expected answer, the expected scores, and the games of how they look, but they need to get into this function. We do that by adding a comment, like so. Not interested in these bits. We want to say the provider, sorry, data provider, and the name of the function. So does it no, we just need to copy paste it like so. So the provider, the data provider for this test is the provide first ball scores. So if we save that and we run it, okay, we can see that this function has run 4 times for each of the arrays it provided. So we can now delete these tests, like so. And we now have collapsed down our tests a little bit. This is where I'm going to stop adding any tests and adding any functionality to our bowling game kata. If you want to look at it, so we've kept this first test, the guttable game test, separate. We've not put that into our data provider because it's a special case. What we are trying to do here is show how we're testing a single case and building up the complexity. So like so. If you want to take over the code at this point and try adding the tests and playing with data providers for testing the simple scoring for the second ball in the frame, and then start building up the complexity and working into spares and strikes, then have a go with this. This is a kind of a really nice way to test functionality and keep the testing concise and small. I hope you found this useful, and I hope you go away and play with data providers and start using them in your projects. Thanks, and I'll see you again soon. Thank you for watching this episode of Testing All the Things. I hope you enjoyed it. If you did, please rate and review the video and subscribe to the channel. If you did not and you have any feedback, please leave a comment in the comment section of the video or contact me on Twitter @Bradle.